Hello and welcome back to our tutorial. In today's tutorial we're going to show you, or we're going to continue with the modification of the modal behavior in the mass spring model in the Ansys APDL, utilizing this spring model you can see here, the one that we analyzed before, of a mass of 25 kilograms, a spring of 25,000 Newton meter, and we're going to change the modal behavior, meaning omega, the frequencies, by modifying the mass in this case instead of the stiffness like in our previous tutorial. So in order to do that, we're going to use the same Ansys file that we used previously. So here we define the model, we define the real elements. If you don't understand these commands, please look at the previous tutorials and follow those, and then you can get back to this tutorial. So the model is the same up to this point, and here we created this array that's called masses. That's a 7 by 1 by 1 array, and it's going to have the next values: 10, 15, 20, 25, 30, 35, and 40. These are kilograms because we're using the international system, and then we're going to assign those values of the mass to the real constant one, which belongs to the mass element that is suspended. And that way we're gonna, by performing the simulation, we're gonna compare the values, and we're gonna look at how the model behavior change by increasing the mass value. So I'm going to proceed just to copy all of this and paste it. So we copy and we paste. So what we have here is the frequency for the last frequency, the frequency value obtained for the last frequency. Here we have on the back, I'm gonna remove this for a second. Here we have on the back the model that we have. So we can activate the E-shape option to check on the model for a second. So we have this spring that's embedded at the bottom and the suspended mass that's on the top. So we take the E-shape of E-shape 0, 0. We can see the results, and the results are displacement on the Z direction, which is the model property, the model value for this situation. So now what we have here is the model results. We're gonna look, and we did this before with Excel, in order to analyze how the modification of the model of the masses act upon the frequencies. You can see that with the slower mass, we know that it's a slower mass because if we look into the text file, we simulated for 10, 15, 20 kilograms. So the smaller the mass is, the higher the frequency is. This makes sense if you look at the equations. Here we have the model and the equation. The frequency is directly proportional to the stiffness and inversely proportional to the mass. So the lower the mass is, the higher the frequency would be. So we're going back here, and we're going to analyze the graphic on the evolution of these characteristics. So we have here on an Excel. I put the frequency values already on this column. Now I'm going to just type these are the mass values. I'm going to just type the frequency values. I'm just doing it by hand because since there are only a few values, it will take me less time to just type these values instead of going and making some kind of routine to import these values or using another little program to getting those values. So I'll just type this thing. I'm going to be finished in a second. 3.9788. So now we're going to graph this. We're going to look at this Excel, and we're going to graph these results. We're going to do a scatter and XY. And as you can see, the variation of the mass according to the frequency is not linear. It's not proportional. In fact, is exactly the result that we will obtain if we plot the variation of a square root of a 1 and 1 divided by a number value, and that what we will obtain is exactly this. But as a general rule, it's important to understand that omega is equal to the square root of k divided by m, k divided by m. Therefore, You can modify the frequency by modifying the stiffness, or you can modify the frequency by modifying the mass. If you modify both, it will be proportional to the variation of the fraction value. So here we have it. The first value is almost 8 thirds, and by increasing 4 times the mass from 10 to 40, we go to 3.97 kilograms. So this is it for today's tutorial. This was a very simple tutorial. It just comes as an addition to the previous tutorial. We hope you enjoyed it. If you did, please subscribe to our channel and hit the like buttons with our videos. Thank you for watching.